decreases.
Hello.
Hello, sir.
Yes, tell me.
Along the period, the enthalpy decreases and down the group increases.
So along the period ionization enthalpy, that one word I didn't hear. Aditi, can you
Decreases.
just come again and tell me?
Yes, sir. Decreases.
Hello.
Hello, sir. Hello, sir.
Sorry.
Hello, sir.
Yeah, tell me.
Along the group, it
It's called as along the
decreases.
period. Along the period. Either it is along the period or down the group. It is not along the
Along,
down, or sorry, along the group or something. Along the period, you must mention.
along the period, it decreases.
Along the period, it decreases. Are you sure? Are you sure?
Sir.
Okay. See, first of all, understand what we have learned yesterday. Okay. Aditi, I don't know whether it was because of the network issue or something. I was not able to hear you properly. But let me just tell you, dear students, that what we have discussed till now, if this is a periodic table, rough periodic table, okay, what we have seen is atomic radius. Okay, atomic radius is something which usually decreases. Okay, decreases along the period and increases down the group. So dear students, I'm just having a quick revision. Okay, I'm just having a quick revision. What the things that we have discussed till now, and that is atomic radius, which is usually don't not measured directly. For the measurement of the atomic radius, we are mainly dependent on the covalent radius and metallic radius and van der Waals radius. And what we have seen here is usually, and when you go along the period, okay, along the period, and when you go down the group, okay, when you go down the group, so let's understand what would happen now. Atomic radius, if you understand, dear students, along the period atomic radius decreases because nuclear charge increases. Okay, just a minute, dear students. And atomic radius down the group, if you go, it usually increases because extra shells will be added every time. After this, we have seen what you mean by ionization enthalpy. Ionization enthalpy is the ability to remove the outermost electron, okay, from an isolated gaseous atom. You should add this. Okay, you should add this before writing, otherwise you lose the marks. Then you have to compare first along the period down the group. Since ionization enthalpy is inversely related to the atomic radius, along the period atomic radius decreases whereas ionization enthalpy increases. So the reason for this one, you can write atomic radius decreases and nuclear charge increases. Now down the group, ionization enthalpy decreases just because atomic radius increases and nuclear charge decreases. Got it? So this is the thing that you have seen. Then after this, yesterday we have seen one more thing, that is electron gain enthalpy. So let's understand what is electron gain enthalpy. It is the ability to release energy, or it is a change in the energy when an electron is added. When you usually add an electron, energy will be released. Okay, and usually again it is inversely proportional to atomic radius. Electron gain enthalpy increases because atomic radius increases and nuclear charge increases, atomic radius decreases. And here it decreases down the group because atomic radius increases and nuclear charge decreases. So this is the general one. Usually, yes Prati, right, usually it is varies in this way. Now we have seen some of the variations. For example, when it comes to the ionization enthalpy, dear students, usually compared with the parent atom, for example, or usually when compared with the ionization enthalpy, along the period, when you compare beryllium and boron, okay, so usually it is along the period, so boron should be having more, but beryllium is having more. Similarly, when you go from nitrogen to oxygen, so along the period it should increase, but it decreases. Similarly, dear students, I can compare with the previous next one also. Beryllium has a magnesium below it, and boron has aluminum. Again, dear students, the variation is observed in case of the aluminum and magnesium. Here it has phosphorus, it has sulfur. See, these four variations are observed. So these four variations are observed, means even though the next element should have a more ionization enthalpy, the next element is having a less ionization enthalpy. Let's hear from someone here. G Sinchana. G Sinchana, can you just answer? Turn on your mic and tell me what is the reason behind this. G Sinchana. G Sinchana, if you can hear, why this irregularity is observed. G Sinchana, I'm expecting you to turn on your mic and tell me if you are hearing this. If there is G Sinchana online, can you just turn on the mic and tell me the reason? Or at least reply why you're not answering. G Sinchana. So if you don't reply, G Sinchana, I'll assume that you're just online, you're just here, but you're not listening to the class. If you're not replying with any things, I assume that you're not listening to the class. You're just turning you're just connected to this class. That's it. I assume in that way. Okay, let's ask someone else. I'll just note down this Sinchana. We'll talk to you. Mahima Naik, can you just turn on the mic and tell me the reason behind this?
Yes, sir. Because um, uh, yes.
So why the next element, even though it is expected that it should have more, but it is having less ionization enthalpy. So what this irregularity is observed?
Nuclear charge, it is less than.
No. Nuclear charge and atomic radius gives a regular value, but irregularity is given by one main thing.
Along the period, it decreases. So
Whatever written here, along the period it increases, but along the period from second, if you go, it is second period, this is third period, but it is decreasing. Only in two cases we are observing here. In case of the beryllium, in case of the nitrogen, in case of magnesium, phosphorus, means in the same group. Yes, you're correct, Prithvi. Let me ask someone else. Mahima, right? Mahima.
yes, sir.
Try to read these things, okay? Because this is the thing that we already discussed in the previous class, right? So you should know this. Okay, let me allow someone else to answer this. Let me ask Ritika. Ritika, can you just turn on the mic and tell me the reason behind this?
So because half-filled configuration is more stable.
So which one is having a half-filled configuration here?
Nitrogen.
Yes, nitrogen and phosphorus. Okay, both have the same configuration of NS2, NP3. Okay, you know why I written N here? It is a general one. Got it? For generally for the 15 group, you write NS2, NP3. You can see it is a half-filled configuration. So what is there in case of the beryllium and magnesium?
Completely filled
But it's not completely filled. It is completely filled
S2.
S2 configuration. So because of these two reasons, it is having the variation here. Okay, means even though it's a previous one, it is having more ionization enthalpy than the next one. Actually, what should be the order? It should be as you go along, it should become more and more. But only in these two cases, it is variation, right?
Yes.
Yes. Okay. Okay, you can turn off. Let me just go for the next one now. Okay. Let me just ask someone. Anirudh Bhatt.
Yes, sir.
So Anirudh, can you just tell me now, which group has a highest value of ionization enthalpy in a periodic table? Which group has the highest value of ionization enthalpy? Anirudh?
Sir, it's noble gases.
Yes, very good. Yes, Shraddha, you are also correct, and yes, Anirudh, you are also correct. It is noble gases. Anirudh,
Yes,
just
sir.
don't turn off your mic. I'm asking few questions here. So your answer is correct. Noble gases. What is the reason for that?
Because they are completely filled
Yes,
configuration.
yes. So whenever they have the completely filled configuration or half filled or at least full filled S2 configuration, they have extremely high value of ionization and enthalpy. Especially in these two cases, they are not having extreme. But the noble gases, it is very, very difficult to take away the electron. Yes. So very good, Anirudh. You can turn off the mic now. Now let's ask someone else. Suraj, Suraj, just turn on. Suraj, just turn on your mic and tell me. Suraj.
Yes, sir.
So can you just define what is electron gain enthalpy?
Sir, it is amount of energy released when the electron is added to the ionized gas.
Ionized gas.
Ionized gaseous atoms.
Yeah, it is amount of
It
energy
is amount
released.
of energy released when electron is added to ionized gaseous atom.
Ionized. It's actually energy released when isolated. Okay, it's not ionized. It is isolated. Okay. Okay, Suraj, see. So usually again it increases along the period, decreases down the group. Okay, but when you go down the group, okay, when you go down the group, Suraj,
Yes, sir.
it should increase, right? Sorry, it should decrease. So from chlorine to chlorine to bromine to iodine, usually the value, first of all, while writing the value, can you just tell me? Actually, Suraj, see this.
Yes, sir.
Pawan has actually a message here that it would be better if you mention as a change in the energy. Why can you mention why change in energy would be better definition than release of energy? Or do one thing, Suraj. You
Yes.
just turn off the mic. Okay, I'll ask someone else now. Pawan, can you just turn on the mic and tell me the reason that why you're defined in this way? Why it would be better? Okay, no, okay. Then Prithvi, can you just tell me? Okay, Pawan, understood. You are using PC, so can't. Fine. Prithvi, can you just tell me?
Because the energy may be released or it may be absorbed in some conditions.
Yes, can you just give me that example where it is absorbed? In which case? In which case it might be absorbed? Yes, Francis, good.
In endothermic reactions.
Where are you getting that endothermic reactions? It's not a reaction. It is just the ability to take electron. That's it. It's just one process. Okay. It's not a reaction. In which case you're gonna get that energy is absorbed. Confused? Your answer is correct, but the reason is somewhat missing. So according to the Prithvi, energy could be released or absorbed. Okay. So instead of mentioning that it is an energy released, it would be better if you define the electron gain enthalpy as energy change when an electron is added. Okay. Energy change when an electron is added. I'm adding an electron. There could be change in energy, means energy could be released or energy could be absorbed. That's a better sentence.
Noble gases will.
Very good, right? So yes, now you can turn off the mic. See, dear students, why it would be better, do you know? In some cases, like the noble gases, okay? In noble gases, when you see like helium, neon, argon, krypton and all, the electron gain enthalpy values are not negative, it is positive here, okay? And you have a clear idea that the sign here indicates that energy is released. The sign, like negative sign, indicates, for example, in chlorine, bromine and iodine, if I use, it's around 347 or 8 something. I exactly don't remember, but it is given this way. This is around 325, this is around minus 298. Understand, dear student, that in these cases usually it is negative. It doesn't mean that's negative energy. It is just telling you that energy is released. Got it? So here for noble gases, they have the positive value. It indicates energy is absorbed. Okay. To add electron also, you should supply your energy only. Okay. So it would be better if you mention that energy change when an electron is added. Okay, majority 90% of the time energy will be released, but in few cases there could be a chance that energy might be required to add an electron. Got it? Okay, now let me just ask one more student here. Murali, can you just turn on the mic and talk to me? Murali? Murali, can you just turn on the mic and talk to me? Or at least you should reply now. What I'll assume is, if you don't reply, I'll assume that, okay, Murali, yes. So now by looking at these values now, okay, minus 348, 325, you can see that electron gain enthalpy value is becoming less and less, okay? 348, 325, 298, it is decreasing. That is what we are down the group, electron gain enthalpy decreases. In that case, fluorine should be having the highest value, right? It should have a highest value. So what is the observation? Is it having more than this value or less than 348? Is it having more or less?
Sir,
You don't remember, right?
no, sir.
Why? You didn't see? You didn't attend the last class?
I didn't, sir.
Then, okay, no problem. But be careful. Listen, okay, Murali.
Okay, sir. Okay, sir.
Shraddha, can you just tell Shraddha? Shraddha, whether the value is less or more. You should turn on your mic and tell.
Yes, sir.
So what's the value now? Is it less or more?
Says it is less, sir.
Okay, so it's coming out to be, I'll write the value. Actually, the values are not required. Still, I'll write the value just for a comparison. Now you answer me why it is having lesser value.
Sir, because it is smaller in size, sir, and it is having 7 outermost electrons.
So
the incoming electron will be repelled, sir. So the by the electron in the present in the fluorine, sir.
What is that one word that you must use here?
Sir, repelled.
Correct. What is that one single word? Oh, sorry, that one, two words. No, that one particular, like a sentence type of thing is there. That particular thing you must use. Yes, Ritika, you're supposed to be. And someone also answered here. Anirudh, yes, good. So that particular word you should use. 3 words are there.
The incoming electron will be repelled by the electron present.
Your answer is correct. It's perfect. But still, it would be better if you use this word. Okay, just a single word. Sorry, 3 words actually. It is called as inter-electronic repulsion. Okay, it would be better if you use this 3 words. Okay.
Okay, sir.
It will be better. Your answer is correct, but it will be better if you use this. It's not Vaishnav, it's not intermolecular, it is inter-electronic. Okay. Oh yes, now it's correct. Okay, Prajwal, it's correct, right? So now let me continue the class. Okay, Shraddha, you can just turn off the mic. Okay, you know the next part in this one is last part in this. Okay, there's last part remaining today is about electronegativity. Electronegativity. Okay. When it comes to electronegativity, one thing is that it is very easy to understand this. Okay, it's very easy to understand, and there is no irregularities. It's directly like almost same. And down the group there could be some irregularities, but it's not that much considered. Okay. So first of all, we'll understand what you mean by electronegativity, and also what's the difference between the 3: atomic radius, ionization enthalpy, and electron gain enthalpy. And the last one is electronegativity. One small change about electronegativity is not the value related to the single atom. Okay, see, just a minute. Yes, just a different than, okay, Rakshita and Prajwal, it's little different than that, but I'll tell you what I was talking about the atomic radius. I was taking only single, okay, one atom. I can just measure the, or I can get the value of single atom. So atomic radius is a quantity of a single atom. Then similarly, if I want to take away electron from single atom, then it is called as the ionization enthalpy. So ionization enthalpy is a measure of single atom, whereas electron gain enthalpy, add an electron to single atom, okay, add electron to single atom, then it would either release energy, majority time it releases energy. So electron gain enthalpy, ionization enthalpy, and atomic radius is the quantity of a single atom, okay, single atom. One atom you take, you can measure the T things. Whereas electronegativity is not the quantity of single atom, it is actually a quantity of a minimum of 2 atoms, okay, it is actually a minimum of 2 atoms. Got it, my dear students? So this is actually a quantity which is measured for the 2 atoms. So when it is usually measured, it is usually measured only after binding or after having a bond here. Got it? There should be 2 atoms to measure the electronegativity. Got it? So now let's understand. See, it's very, very easy to understand. See here, if imagine this is an atom now, okay, this is one more atom now, okay, this is an atom now, this is one more atom, and this atom is a larger one, this is a smaller one. Now usually they form a covalent bond, okay, usually they will form a covalent bond, and electronegativity is usually measured for the covalent bond only. Once it is measured, the value will be given to particular element only. It is given to particular element, but for measuring you should have at least 2 atoms, they should have a bond now. Got it? So let's understand this. So how the covalent bond will be formed now? So this atom, see, I'll tell you how the covalent bond is formed. Imagine, okay, imagine I'm one atom now, okay, I'm one atom and I have only one electron, okay, imagine I'm an atom now, I have one electron, so I will share my electron with one more atom which is standing over here. Got it? So try to understand the situation now, that there are 2 atoms now, they want to share the electrons with each other, okay, so I will share my electron and this atom also shares its electron. So by this way we're gonna share the electrons like this, okay, I hope you're understanding. We, okay, we, this person standing here and the person standing here are sharing the electrons. Clear? Fine. So this is how they're going to form a bond now, and it is a covalent bond. So but once the covalent bond is formed, one among these 2 atoms will be stronger, okay, they will be having a stronger nucleus. So what they're going to do is they will try to pull the share of electrons towards itself, okay. So when they form a compound, okay, when they form a compound by sharing of electron or a covalent bond, one of the atom will attract the pair of electrons, shared pair of electron towards itself more strongly compared to the other one. Got it? Imagine I'm and a student of like, or a person of a like 5th standard student, okay, imagine a student of a 5th standard, we are trying to share electron, okay. So what we'll be doing here is, since I'm little stronger than him, so definitely I'll pull those electrons towards myself, right? And that person or that 5th standard student who's not having that much power might not be able to pull, he has to give, might not be able to pull that electron, so he might give the electron towards me. I'm not telling that it's completely transferred, but it is little towards my side. Got it? It is little towards my side. Got it? You can imagine the situation like traveling in a bus also. So imagine if 2 persons are sitting, if one person is little stronger, he would occupy more space in a single seat only. You might have seen the bus is having like a double seater bus, okay, even though it is okay, it's the single person should occupy single seat, a person who's stronger or little fat might occupy more space because the other one might be a little weaker, right? So this is what happens. See, now let's come to the direct scenario where one electron is shared by this atom and other electron is shared by this atom. Now between these 2, dear students, between these 2, one of the atom will be little more stronger. It is more powerful in attracting this pair of electron. What type of electron is this one? Shared pair of electrons, okay. And this ability to attract the shared pair of electron by an atom in a compound is called as electronegativity. Dear students, is that clear now? So the ability to attract the shared pair of electrons by an atom in a compound is called, okay, that ability is called as a electronegativity. Let me just ask you one simple question, dear students. Imagine this nucleus and this nucleus is almost the same power, okay, same power. And if this is A and B, can you tell me which is having a more capacity to attract the pair of electrons now? Can anyone reply and tell me between A and B which might be having more power to attract? Yes Francis, yes Rakshit, yes, no Prithvi, no Prajwal, no. I'm telling you that this is a magnet type of thing which is equally powered. Now tell me between A and B which is more powerful to attract. Think and tell me. So are you sure, Anirudh? Are you sure it is a neutral? Aditi, are you sure that it is same? Because I'm telling you that I'll make it very simple for you, okay? I'll make it very simple for you. This is one magnet, okay? This is one magnet. This is iron nail now, okay? I will make it very simple for you. See, this is an iron nail and this is the magnet. And this is one more magnet, okay? Just imagine the scenario now. Just imagine the scenario. This is kind of a type of atom and this is B type of an atom. Now tell me who has the more capacity to attract, even though the ability to attract the magnetic field is same. But based on the position, you have to tell me now. So between A and B now, who has a more capacity to attract the nail, iron nail? Yes. Now I think it is clear, right? Now I think it is very clear. Why the B is having more ability to attract this iron nail is, this iron nail is close to the B, whereas this iron nail is far away from it. Got it? Yes, Anirudh, very good, right? It is closer. The same way, can you compare and tell me now, if this is kind of a magnet, this kind of a magnet, who has the capacity to attract now? The same way, B has a more capacity to attract. Got it? Now I think it is clear, right? So dear students, now it is very clear to understand electronegativity is dependent on nuclear charge and again on the atomic radius. Got it? So if an electron is shared, imagine if this atom X and Y shares atom. Now you can see clearly, dear students, the pair of electrons is far away from X, whereas very close to the Y. So it has a more ability to attract. Got it? In that case, I can assume in this way, this might be having a more electronegativity than this one. So this might be having a more electronegativity than this one. Why? Because its size is smaller. Is that clear, my dear students? So in that case, how they are related then? Electronegativity is coming out to be larger for a smaller one. So electronegativity is again inversely proportional to atomic radius. Got it? And if two sizes are there, okay, if the two atoms are there of the same size, dear students, now also you should answer now. Two atoms are there which is M and N, okay? Two atoms are there, M and N. And this has a nucleus which is very, very, very powerful. And this has a nucleus which is not underpowered, okay? But the distance between the shared pair and the nucleus is same. Okay, this is same. So now can you tell me between M and N which has a more capacity? Yes, Pawan. Yes, Anirudh, right? So now it is very clear to us that if nuclear charge is more, ability to attract is more. If size is more, ability to attract is less. Then how we can understand the electronegativity and its dependence on the size and nuclear charge? Again, it is same as ionization enthalpy or as electron gain enthalpy or even electronegativity. They are directly proportional to nuclear charge. All the three, okay? All the three are directly proportional to nuclear charge and it is inversely proportional to atomic radius. Done. Got it, dear students? So don't write because we need to write the definition and all. I hope this is clear to you. Dear students, is that clear now? Is that clear now? You can see the things here only. Since along the period this is decreasing, this is ionization enthalpy, electronegativity, electron gain, everything will increase. Got it? I hope this is clear. Okay, let's compare along the period down the group again afterwards, but let's complete the definition. So can you just write the definition then? So what is electronegativity? Electronegativity is the measure of, I'll write here, okay? It is the measure of ability to attract the shared pair of electrons. It is the ability, See, dear students, one word is missing. Please add it. Measure of ability of an atom in a compound. This word should be added here. Okay, it is a measure of ability of single atom to in a compound to attract the shared pair of electron towards itself. Got it? So towards itself, its ability to attract the shared pair of electrons is called as the electronegativity. Got it? So now you can write electronegativity is directly proportional to nuclear charge and inversely proportional to atomic radius. Okay, so then we can write the variation along the period now. So along the period, so dear students, can you complete and tell me now? Along the period, electronegativity, okay, electronegativity increases. Very good. Why? Because atomic radius is atomic radius is decreasing, electronegativity should increase. Got it? Electronegativity increases because atomic radius decreases and nuclear charge increases. I think you have understood now that this is a common sentence used for all the ionization enthalpy, electron gain enthalpy, as well as electronegativity. Got it? Yes, nuclear charge increases, atomic radius decreases. Got it? Now variation that is along the period is done. Let's compare down the group. Okay, let's compare down the group. So what would happen down the group? Down the group, electronegativity decreases because atomic radius increases and nuclear charge remains same. Okay, nuclear charge means effective nuclear charge remains same. Got it, dear students? Is that clear now? I think it is clear, right? It's very easy concept. And also variation is irregularity is not that much. If you compare, see, actually the value is not required. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay. Usually the second period elements are the smallest one, so they have the highest value. And in that, lithium is having only 1.0, the value, okay, the value which is usually done by the Pauling's scale. Okay, Pauling's scale. In competitive, I'll tell you what is that scale and all. Now for the boards, we'll have a quick understanding. That's it, enough. Okay, you can see along the period electronegativity is increasing. Along the period electronegativity increases, so it is increasing. 2.0, 2.5, this is 3.0, this is 3.5. So fluorine, it is 4.0. Can anyone tell me what is the value for the next element? Next element is neon. It's actually kind of no unit. Okay, don't worry. It is just a comparison. Are you sure, Ritika? Anirudh, very good. It's correct. Ritika, are you sure? Shilpa, think and tell me. It's not always this what you see. You should understand. Ritika and Shilpa, think and tell me whether your answer is correct. Because I'll repeat once again, electronegativity is not the measure of single atom. It is usually calculated only after combining with some other element. Now, can you tell me, Ritika and Shilpa, what should be the value for this electronegativity for noble gases? Anirudh, your answer is correct. Yes, Aditi. Yes, Vaishnav, correct. Yes, that's why I'm asking what's the value now. Yes, Shilpa, now it's correct. Ritika, what should be the answer now? Yes, Pawan. Sorry. So, Ritika, if you are there, can you just reply? Yes, no electronegativity means 0. Okay. Yes, that's on. See, that's while giving the value I stopped up to here because I was expecting the same value, but understand this is not forming any bond, so therefore the electronegativity would be 0. Got it, dear students? So it is 0 now. So, and also we don't measure for the noble gases, it's up to fluorine. So in that case, dear students, if you go down the group, okay, Here only I'll compare. Okay, here only I'll compare. What would happen when you go down the group? For example, you know the lithium family. When you go down, you will get the sodium or potassium, rubidium, like that. Whereas fluorine family, you will be getting around chlorine, then bromine, then iodine. Okay, so definitely down the group it should decrease, right? And it decreases. For example, for sodium you will be getting around 0.9, for potassium it's around 0.8, but down the group the value almost remains constant, dear students. Okay, almost constant. The cesium is having a 0.7. okay, cesium is having a 0.7. Let's go to the this side now. Okay, chlorine is having around value of 3.0, close to 3.0. Bromine is having around 2.8 or something. Iodine is having around 2.7 or something. Down the group, electronegativity decrease is not that much. It decreases, sometimes it remains constant, sometimes even increases by slight value. So we not worry about the last few elements. Okay, you will understand why it happens, but not now. Okay, don't worry. So dear students, is that clear now? So you can see it is decreasing, but at the beginning it is decreasing high value, but down the group it is becoming almost constant. So dear students, I will ask you, it is because, not because of the only nuclear charge, effective nuclear charge, it is because there is something, one effect called as a shielding effect or screening effect. Okay, there is something called as a shielding effect that I will explain during the competitive. Now it is not required. Okay, I will explain that during the shielding effect. I don't know whether I've explained or not, but because of that, the electronegativity becomes almost constant here. So dear students, after understanding this, let's write a note here. Therefore, the most electronegative element in a periodic table, Can you tell me now, what is that element which is very, very most electronegative in the given? Yes, it is fluorine. Right hand, okay. Top right hand, you will be getting the highest electronegative, that is fluorine. Yes, those are answering. It's correct. And the most electropositive. What do you mean by electropositive? Exactly opposite of this. Okay, means they don't want to have that electron, they want to give that electron. So anyone, can you tell me the most electropositive, opposite of this? Okay, or the least electronegative? Least electronegative or most electropositive? Both are same. Okay, not lithium. Sanjana, Aditi, think the values are in front of you only. I think someone, yes, Francis, it's correct. Francis, Anirudh, it's correct. Right, see the value is here, cesium. Okay, the most electropositive or the least electronegative, both are same. Element in the periodic table is cesium. Okay, is that clear now? Cesium. Yes, got it, my dear friends? Is that clear now? Have you understood anything, everything related to the electronegativity? So if this is clear, there is one small concept that I want to tell, and there are actually some concepts that are given in the competitive class, this NCRT, but dear students, mainly some concepts I will be discussing on the competitive part. Now boards level, this is enough, more than enough. Okay, is one last point that I want to mention here is about the metallic nature. So first of all, you should understand when an element can be called as a metal or when it can be called as a non-metal. There is no such exact distinction. Okay, but you can call a metal. Okay, usually metals will have. Okay, usually metals will have, actually on based on these three only should be understood. When we can call an element as a metal now, usually metals will have low ionization enthalpy. What it indicates, their electron can be taken out easily. Low electron gain enthalpy means by, if you want to give, yes Rakshit, based on that also I'll explain. Usually metals will have low electron gain enthalpy, means when you give an electron, they won't release much energy, means they don't have that much attraction for that. Or low electronegative. Okay, low electronegativity. Okay, so they will have a low electronegativity or more electropositive. Got it? Dear students, is that clear? So these are actually the values that will decide. Okay, these are the main thing that decides the metallic nature of anything. Got it? So in that case, can you tell me, usually ionization enthalpy, high ionization enthalpy, high electronegativity, high electron gain enthalpy, usually found in which side of a periodic table now? On which side of a periodic table? Let me just mark the periodic table for your understanding, that if this is a periodic table now, this is lower end. Okay, this is lower end. This is lower right, left end. This is lower left end. This is top right end. This is top right end. This is lower left end. Yes, yes. Usually you're gonna get the value, highest value, that side only. Okay, you will be getting that highest value on the top right hand. See, you can see along the period it is increasing. Means in this way it is increasing. Down the group all the values are decreasing. Means again the top value will be more. Okay, your top right hand it will be more. Okay. So usually that's the reason, dear students, you're gonna get all the non-metals in this side and all the metals on this side. Got it? So if you want to draw a periodic table, dear students, see, usually you can understand in this way. By understanding this, if I draw in this way, metallic nature, okay, metallic nature in this way decreases. Okay, but whereas when you go down the group, metallic nature increases. Got it? There is one simple hint that will clear all your doubt. You know what is that? I hope you know about mobile. Down the group, when I ask you, I hope you know about this mobile, very famous mobile. What is that mobile? MI company, MI brand, right? You know why I'm taking this one? Because this will help you to help you to remember. What is that? Down the group, metallic nature increases. Dear students, is that clear now? See, metallic nature increases. How? Down the group. Got it? So down the group, when I'm comparing, metallic nature increases. Got it? So when I compare, can you tell me, dear students, between lithium and sodium, which is more metallic? Between lithium and sodium, which is more metallic? Between lithium and sodium, which is more metallic? Yes, Rakshit. Yes, Aditi. Sodium is more metallic. Why? Because down the group, metallic nature increases. Okay. So lithium is less metallic, sodium is. So can you tell me between fluorine and between nitrogen and phosphorus, which is more metallic? Which is more metallic? It is phosphorus. Very good. Right. Now when I compare like this, then between the lithium and fluorine, which is more metallic? Between lithium and fluorine, because they are now along the period. Yes, it is lithium. Okay. Along the period, metallic nature decreases, but down the group, Mi, metallic nature increases. Okay. Therefore, lithium is more metallic. Got it, dear students? Is that clear now? Is everything clear now? Yes. Okay. So let me just ask few of you again, few questions here. Don't leave. Don't leave. Let me ask to Sujal Kauri. Can you just turn on the mic? Sujal Kauri.
Yes, sir.
Sujal. Sujal Kauri, can you just turn on the mic?
Sir.
Okay.
Yes, sir.
So can you just answer what is isoelectronic species? Can you just tell me what is isoelectronic?
Isoelectronic is the magnetic effect of electron and proton.
Is that it? So there could be something extra. Or in a simple way, you should tell what is isoelectronic species. Sujal, can you just turn on the mic and answer?
The
What happened? Yes, Mahima. Yes, Prajwal. Okay, I don't know what has happened with Okay, Deepika, can you hear me? Deepika, turn on your mouthpiece. Oh, there's no Deepika here. Okay, let it be. Vaishnav Kauri, Vaishnav. Vaishnav, can you hear me? Can you just turn on your mic?
Yes, sir.
So tell me now, what is meant by isoelectronic species?
The electrons are the ions which have same number of the elements are ions which have same number of electrons.
It would be better if you mention a different elements, okay? Different elements which have the
Okay.
same number of electrons. Okay,
Okay, sir.
just give me the example for that. Just give me the example for that. You're turning the page or what?
No, sir. Examples. Sir, don't know.
Don't know. You tell me at least, what is the number of electrons in sodium?
11.
Can you make it as Na plus?
Sir,
Means by?
losing of one electron.
Yes. Then how many electrons will be remaining?
10.
Yes, right. Similarly, take the magnesium. What's the atomic number of magnesium?
12.
So remove 2 electrons. How many electrons will be remaining?
10.
Yes. And what it is called as Mg?
2 plus.
Yes. So therefore, example would be Na plus and
Mg2 plus.
Mg2 plus. Got it?
Yes.
Okay. So can you just answer one more question to that only?
Yes, sir.
Between Na plus and Mg2 plus, which is larger? Between Mg2 plus and Na plus, which is larger?
Na plus.
Very good. Okay. So if you want to remember, I told you cations, you take it as cations. Okay. If you are taking Mg2 plus means you are cutting 2 times. If you cut something 2 times, it becomes smaller. But sodium, it is only Na plus means you are cutting only once time. So if you cut 1 time, it becomes larger. Got it?
Okay,
Larger
sir.
means compared to Mg2 plus, it is larger.
Okay,
Yes,
sir.
yes, very good. Then last to someone else. Brunda.
Yes, sir.
So Brunda, can you answer what you mean by electronegativity and how it varies?
Electronegativity, it is a measure of ability of an atom in a compound to attract the shared pair of electrons.
Okay. You just recalled or you just read from the book? You recalled, right? Okay. Then tell me how it varies.
Along the period, electronegativity increases and atomic radius increases and nuclear charge also increases.
Everything increases.
And down the
Everything increases. What you are answering is everything increases. Electronegativity also increases. Atomic radius also increases. Nuclear charge also increases. Is it in that way? Or yes, Ritika. Atomic radius should decrease. Okay.
Okay, sir. And down the group, electronegativity decreases and atomic radius increases and nuclear charge remains same.
Okay. Fine. You can just turn off and okay. So dear students, okay, Brinda, thank you. So dear students, with that, I'll tell you that the third chapter to the boards level, it is over. Okay. And this chapter is there for the upcoming test. So be prepared. Very easy questions. I will send you the questions also. Okay. Some important questions I'll share with you in the group today only. You can write the answer and you can consider it as an assignment, and you can just upload whenever, I mean after the exam. Okay, there is no such thing as you have to write now only. I'll start. Okay, we'll start. We'll think about it, Francis. We'll let you know. Okay, Pawan will let you know. Okay, the comparative classes. I wanted to start once to come here, because it should be more interactive one. So that's the reason I'm just waiting. But again, if it does not start from next within 5-10 days, I'll start the class, competitive class here only. Okay.